Physics with Nunez. Welcome to Physics with Nunez. Today we're going to be talking about charging by conduction or charging by contact. And so to get started, let's say we have two objects, two metal objects, two metal spheres. And because we know metal is a good conductor, inside of that metal, we've got some protons and we've got some electrons. So I'm going to go ahead and represent our protons with a plus and our electrons with a minus. And right now, the way that I've drawn them is I've drawn them as two neutral spheres. We know that they're neutral because they have 4 positive charges in each, and they have 4 negative charges in each. And so together that means they have a net charge of 0. But let's say, I had a slightly different situation where instead of having 2 neutral spheres, one of my spheres was already charged. Let's say it had 4 positive charges, and the other one has 4 positive charges. And we'll keep our left sphere neutral, but our right sphere only has 2 negative charges. So if we look at this now, we have 4 positive in each sphere. We have 4 negative charges here and only 2 negative charges here, which means on the left we have a net charge equal to 0, and on the right we have a net charge equal to positive 2. Okay, so what would happen then if I were to take this sphere and bring it in contact with this sphere? So when you take 2 conductors and bring them together, the important thing to remember is that electrons are able to flow freely inside of them. So the protons are essentially bolted in place. They can't go anywhere. They're bonded in the nucleus. But the electrons, however, are free to move. And so now, because the charge on the right is positive, it's actually going to attract some of the negative charges from the sphere on the left. So one of those negative charges is actually going to leave and come over to the sphere now. So we have 3 negative charges in both. We have 4 positive charges in both. Which means we have a net charge equal to positive 1 in both of them. And this will always be the case for identical objects, meaning for objects of the same size. The charge after contact will be the same. And it's equal to 1/2 the original net charge. What do I mean by that? If we look at the total charge of our system at the beginning, the total charge was 0 plus 2, which means that the total charge was 2. And so down here, we see that the total charge does not change, but the charge of one individual sphere is equal to the original charge divided by 2. So the original charge divided by 2 means we have a charge of 1. That's all we've got for today. See you guys in the next one.